Hello. Hello everyone. Today we are going to show you the different aspects of vector. In the previous classes we have learned the addition of vector addition in different forms. That is, first one what we called it as triangle law of vector addition, the second one is known as parallelogram law of vector addition, and the third one is known as polygon law of vector addition. Today we will discuss with another thing, that is displacement and position vectors and displacement vectors. So here you can see how we are dealing with these two types of vectors, that is what we call it as position vectors and displacement vectors. You see, we are going to explain what is the position vector and displacement vector. Now you can see here that first of all we discuss about the position vector, and we'll also discuss about the displacement vector. You can see here that position and displacement vector, how it can be defined. First of all, we learn about position and displacement vector. Position and displacement vector. Position and displacement vector. Position and displacement vector. Now position vector can be defined, and how the displacement vector can be defined, that I am going to discuss with you. You see here how we are going to discuss this one. Now we will deal with position and displacement vectors. Position vectors can be represented in this way. The vector which gives the position of an object with respect to the origin of a coordinate system is called the position vector. It is represented by r. Suppose this is the coordinate. This is the OX axis, and this is OY axis. Right? Suppose I represent a position. Suppose this one is represented by position P vector P, and this is represented by vector R. This is called it as position vector, right? And suppose this particle goes from here to here, and it is represented by P dash. And you see the distance is suppose del R, or change in R. This is R vector, then this is R vector, and so this is the resultant vector. You see, this is the resultant vector, and we call it as R dash. We call it as R dash vector. R dash vector. So here you see this is a position vector, and you displaces vector R del R from here to here, and this is the R dash vector. Therefore, we can write that R dash vector. We can write here that R dash vector can be represented here. R dash vector can be represented as R vector plus del R vector. What is the del R? Del R is a change in the displacement vector, and this del R is the what we call it as the displacement vector, and this is the R vector, and this is the R dash vector. The R dash vector can be written as R vector. You see, we according to triangle law of vector addition, you can say R vector plus del R equal to R dash equal to R vector plus del R vector, and this is known as the resultant of R dash, R plus del R. Here you can say that del R is the displacement vector. A vector which gives the change in position of an object in a particular direction is called the displacement vector, and it is represented by del R. Del R is a vector, and it is a displacement vector. Displacement, you can see here that it is actually displacement vector. It is displacement vector. This is what we call. So we can see here that P is the position vector and del R is the displacement vector. And Taylor can be written, if you want to find the displacement vector del r, then it can be written as r dash vector minus r vector. R dash vector minus r vector is the displacement vector, right? So you can find in this way the displacement vector and position vector, right? And OP and OP dash are the position vectors. OP and OP dash are the position vectors of a particle, right? So therefore you can say del r is the displacement vector and P and P dash are the position vectors of a particle at a time at time t and t dash. Suppose at time t it is P and at time t dash the position is P dash. Therefore these are the position vectors. This is the del r is the displacement vector. In this way you find the displacement vector. If you remember the magnitude of the displacement is either the magnitude of the displacement is either less or equal to the path length of an object between two points. So it is very clearly you can say here that P and P dash are the position vectors, right? And del r is the displacement vector. So displacement vector can be written as del r equal to r dash minus r vector. In this way you can find the displacement vector. And P and P dash are the position vectors at time t and t dash. So you can find in this way the position and displacement vector, right? In this way you can find the displacement vector. But remember that the position may be changed in different ways. Even then we get the same result, as the position vector is the displacement vector is the least distance from initial point to final point, and that is the vector. That is, we know all these things, right? Now we learn this. So we learned about position vector and displacement vector, right? So you see this P dash is the position vector, P dash is the position vector at time t dash, and del r is the displacement vector. So del r can be represented in this way, that del r equal to r dash vector minus r vector. This is displacement vector, right? And since displacement is also a vector, we can say, right? This is the displacement. So in this way we can find the position displacement vectors. Now we learn about resolution of vectors. In the same way we have addition. This is, we learn about resolution of vector, how to find the resolution of a vector. Resolution of a vector. Resolution of vectors. Actually the resolution of vectors is the opposite of addition of vectors. Suppose we are adding two vectors. Suppose this is vector A, we are adding with vector B. This is vector B, this is vector A. We add the vectors, we get the resultant in this direction, but initial point of the first vector and final point of the last vector, that is the resultant. We are getting this A vector plus B vector, A vector plus B vector, right? So this is the resultant. In another way you can resolve this vector also. Suppose this is a vector R. Suppose this vector is there, vector R is equal to vector A plus vector B, vector A plus vector B. They can resolve this vector in two directions. One is OX direction and on Y direction. OX direction and also in OY direction. This is known as resolution vector. Resolution of vectors can be resolved in three axes, OX, OY and OZ also, right? In two dimension cases you see this R can be represented, R can be resolution into two ways. If it is 90 degree between A and B, then if the angle between A and B, and this is the angle theta, then this OX can be represented as R cos theta, and this OY can be represented as R sin theta. So you can say that these are the resolution of the vectors R, right? How to resolve the vector? We can say here that you see that OX along the OX direction it is R cos theta. Theta is the angle between r vector and ox vector, or you can say this vector, that is a vector, right? And oy equal to r sin theta, right? In this way you can find the resolution of any vectors. We can resolve this into three directions also, that is ox, oy and oz. Also we can resolve it. The resolution of vectors means that the opposite of addition of vectors. Opposite of addition of vectors, that is resolution. Opposite of addition of vectors. Opposite of addition of vectors. That is the resolution of vectors. This we call it a resolution of vectors. So you can, if you resolve this one in 90 degree, this r cos theta and r sin theta will be resolution along ox direction and oy direction. Ox will be r cos theta and oy equal to r sin theta. And theta is the angle between r and a vector. Suppose this is a vector and this is b vector. So you can replace this one in this way. So the components of vector along 2 or 3 mutually perpendicular axes are called rectangular components of the vector, right? Not only that, vectors A can be resolved into coplanar vectors A and B. Now you can say that vector A can be resolved along two coplanar vectors A vector and B vector. A vector and B vector as shown below, and can be represented as vector A equal to lambda A plus mu B vector, where lambda and mu are real numbers. So you can write vector A as lambda A plus mu B, or you can represent in this way. Suppose this is vector A. It can represent it in this way, that this is lambda A and this is mu B, lambda A plus mu B. This is mu B vector. So A can be represented as lambda A or A lambda plus mu B, where lambda and mu are the real numbers. So in this way we can define. Now we learned about the unit vectors. Unit vectors can be defined in this way, that we already learned in the previous chapter what is about unit vectors. Unit vectors. We defined unit vectors in the previous classes, that n unit vector is equal to a vector by modulus of a vector. We already learned this one, that unit vector is n unit vector equal to a vector by modulus of a vector. And if we find the unit vectors along ox, oy, oz direction, these are known as ijk vectors. That is I unit vector along x direction, j unit vector along y direction, and k unit vectors along, this is o, x, o, y and o, z. These are known as unit vectors along ox, oy and oz. Ox, oy, oz of a rectangular coordinate system of a rectangular of a rectangular coordinate system, coordinate system are denoted by I unit vector, j unit vector, and k unit vector, and these vectors are these unit vectors are perpendicular to each other, perpendicular to each other, right? And the modulus of I vector equal to modulus of j vector equal to modulus of k vector, and that is equal to 1. So you can say that I dot I vector equal to j dot j vector equal to k dot k vector equal to always 1, and if you multiply I dot j, since they are perpendicular, their constant is 0, it is 0. I dot j dot k, it is also 0. K dot I, it is also 0, because they are perpendicular to each other. And if they are perpendicular, the formula is A dot B modulus of A. You know that A vector dot B vector is represented as modulus of A, modulus of B, and cos theta. And if the theta between them is 90 degree, it is 0. So I dot j, j dot k, and k dot I is equal to 0. This we learn all these things. So if we represent vector A in the xy plane, suppose there are two-dimensional plane, xy plane. This is OX, this is OY, and there is a vector A vector. This is a vector A. So we represent it here as this is the AXI, and this will be the AYJ vector. So vector A can be represented as AXI unit plus AYJ. And if you want to find the modulus of the vector, suppose this is theta, then you can write AX is equal to A cos theta, and AY equal to A sin theta. If we by resolution, right? By resolution we got this one, and we found the modulus of the vector A, then we are getting root over of x square plus ay square. This is the modulus of vector A. And if you find the angle, that is theta, then you are getting, and the direction if you want to find, then tan theta will be ay by x. In this way, we find the vectors in xy plane. In xy plane, we find this one, right? And suppose this is vectors in xy plane, vectors in two dimension, that is x and y plane. If we use three-dimensional vectors, that is vector space, vectors in three dimension. Now we learned about vectors in three dimension. Vectors in three dimension. Then it can be represented as in this way, that in this way you can write here, this is OX, OY, and OZ. And if there is a vector A, This is vector A making an angle alpha with x-axis and beta along y-axis, beta along y-axis and gamma along z-axis. This is gamma along z-axis. Then find that Ax can be written here as A cos alpha. Ax can be written as A cos alpha, A cos alpha. Ay can be written as A cos beta, and a z can be written as A cos gamma. Right? Then we will find the modulus of A. Suppose vector of A, we can find here as in this way, that Axi plus Ayj plus Azk. This can be represented in vector A. If we want to find the modulus of this vector, then we are getting this one is in this way, that root over of x square plus ay square plus az square. In this way you can find the root over of vector A. A position vector R in space is expressed as a position vector R in space is expressed as R vector equal to xi plus yj plus zk vector. Right? In this way you can find these values. Right? So in this way you can find the different vectors in 3 dimensions. Right? And in 3 dimensions you also know, if you find the direction cosines, then you get the values that cos square alpha plus cos square beta plus cos square gamma is equal to 1, or cos alpha can be written as L square plus m square plus n square equal to 1. This is the direction cosines, that is cos square alpha plus cos square beta plus cos square gamma equal to 1. This is the direction cosine in 3 dimension vectors. Right? In this way you can define all these things. Right? Now we can define the various things in motion in a plane. Now we discuss about the motion in a plane, how we get the motion in a plane factor. Right? So we get the vectors in 3 dimensions, that is A equal to Axi plus Ayj plus Azk. Right? And we also got this one, is cos alpha equal to Ax by A. Right? Ax equal to A cos alpha, or cos alpha can be written as X by A, that is cos alpha. Right? Now we will find the cos square alpha, we find the direction cosine, then cos square alpha plus cos square beta plus cos square gamma equal to 1, or you can write L square plus m square plus n square is equal to 1. Right? Now we will find the motion in a plane. We will define what are the different things we present in motion in a plane. Now we will learn about different things in motion in a plane. Motion in a plane. There are various things we are present in motion in a plane. The motion of a body, that takes place along 2 different directions, coordinate axes with respect to origin at the same time, is called 2-dimensional motion or motion in a plane. If the dimension is 2, that is Ox and Y, this is Ox, this is Oy, ambient displacement in this way. This is the position vector. The motion of body that takes place along two different directions with respect to origin. This is the origin. O is the origin. With different O is the origin. At the same time is called the two-dimensional motion or motion in a plane. So vector r in two dimension can be represented as vector r equal to xi vector plus yj vector, yj unit vectors. And we want to find the modulus of the vector. And we will find that modulus of r vector we will get with the value as root over x square plus y square, x square plus y square. This is the modulus of the vector r. And if you want to find the displacement vector, suppose this is r, and we already found this is r vector and this is another vector r dash vector, then this will be the resultant vector, or you can say it as del r vector, del r. This is the displacement vector. So we can write that del r vector is equal to r vector minus r dash vector minus r vector, and this del r is known as the displacement vector. This is known as displacement vector. Displacement vector. So we are getting this displacement vector here, and it can be written in this way. R dash can be written as x dash I plus y dash j minus xi plus yj. So you can find here as I del x, that is x dash minus x plus j y dash minus y, or you can written as del xi plus del yj. This is the displacement vector. Del r is equal to del xi plus del yj. This is the displacement vector. So you can find the displacement vector in this method, that del r can be found. This is the displacement vector. Displacement vector del r equal to this one. If you want to find the average velocity, now number 2 is average velocity. What is that average velocity? Average velocity. The average velocity v dash of an object is the ratio of the displacement del r and the corresponding time interval del t. Mathematically we write del average velocity as del r by del t, del r by del t, and it can be written as I del x by del t plus it unit vector plus j unit vector del y by del t. This is the average velocity. Or you can write average velocity in this way, that it is can be written as vx I plus vy j unit vector. This can be written in this way, average velocity. The direction of the average velocity is the same as that of del r, and the direction of average velocity, the direction of the average velocity of the average velocity the direction of the average velocity is the same as that of del r, is same as that of del r, and that is displacement vector, right? The average velocity is same, right? Now the next one is instantaneous velocity. Third number what we want to define is instantaneous velocity. This is very much important. Instantaneous instantaneous velocity. What is that instantaneous velocity? If you want to find instantaneous velocity, the velocity or instantaneous velocity is given by the limiting value of the average velocity as the time interval approaches 0. The instantaneous velocity can be written in this way, that is, it is limit del t tends to 0, del t tends to 0 of average velocity, or you can write limit del t tends to 0 del r by del t, or you can write it as dr by dt. That is differentiation of position vector with respect to time. So you can say that velocity, instantaneous velocity, is given by the limiting value of the average velocity at the time interval approaches 0, that is dr dt, right? And the direction of velocity at any point on the path of an object. What is the direction? The direction of velocity. The direction of velocity at any point. The direction of velocity at any point on the path of an object, on the path of an object, is tangential to the path, is tangential to the path, at that point and is in the direction of motion, and is in the direction of motion, This is known as instantaneous velocity. So you have to remember all these factors, that is, what is displacement velocity, what is average velocity, what is instantaneous velocity, that is dr dt. And we find that the direction of velocity at any point on the path of an object is tangential to that point and is in the direction of motion. And if this can be represented as 2D, in 2 dimension, so you can write it here as in this way, that v vector represented dr by dt, and that can be represented as this way, that is dx by dt into I vector plus dy by dt j vector plus dz by dt into k vector. This can be presented as b, right? If with 3 dimension, so once we are taking 2 dimension, we write only 2 factors, that is only up to j vector. Suppose this is not, we are taking 2 dimensional vectors, then this can be written as in this way, right? Therefore we are getting this one. Therefore we are getting dx by dt is how much? Dx by dt you can write here as, this is the vxi, right? Vxi plus this is vy j vector. This is vxi, this is vy j vector. And if you find the modulus of this vector v, we are getting root over of vx square plus vi square, vx square plus vi square. We know this one, this is the modulus of the vector, and where you can write here as vx equal to dx by dt and vy equal to dy by dt. Okay, and if you find the direction of v, and direction of v can be found out by direction of v can be given by tan theta equal to Vy by Vx, or you can write it here in this way, that theta is equal to tan inverse of Vy by Vx. This is theta. So this is what we get the velocity component. Now if you find the average acceleration, what is the average acceleration? Now you find another term, that is 5 is average acceleration. Average acceleration. What is that average acceleration? That average acceleration A of an object for a time interval del t moving in xy plane is a change in velocity divided by the time interval. That is, find average velocity A average. It can be defined as del v by del t. Del v by del t. Change in velocity with respect to change in time. And del v by del t can be written as del vx by del t into I vector I plus del Vy by del t into j vector. This is the average acceleration, or you can write average acceleration as axi plus ayj, where ax and ay are the acceleration in the x and y directions. This is known as average acceleration. Now we learn another term, that is instantaneous acceleration. Instantaneous acceleration. Instantaneous acceleration. How to find? The acceleration or instantaneous acceleration is the limiting value of the average acceleration as the time interval approaches 0. That is this one. You can write it here as in this way. The limit del t tends to 0, del v by del t, del v by del t, or you can write it as dv dt, dv by dt, rate of change of velocity with respect to time, that is instantaneous acceleration. And it can be written as ax I axi plus ay j, where ax is equal to dx dvx by dt, and ay is equal to dvy by dt. So we are finding the instantaneous acceleration as axi plus ay j, or you can write it as dv dt. In this way you can find all the definitions of motion in 2 dimensions. And if we find motion in a plane with constant acceleration, then we find 3 laws, right? Now we find the motion in a plane with constant acceleration. We will find the next thing, that motion in a plane with constant acceleration. Motion in a plane with constant acceleration. Motion in a plane with constant acceleration. Suppose an object is moving in xy plane with constant acceleration a. Let the position and velocity of an object be r0 and v0 at time t0 and rb at any time t. Then it can be written as number 1. I am writing only the formula, that v0 equal to v0 plus at, number 1. In terms of component, vx equal to u0x plus ux. If we term the component, then vx we can be written as in this way, that u0x plus ax into t, and v y can be written as u0 y plus ayt. This can be written in this way. And number 2, average velocity can be written this way, that v0 plus v by 2. This is the average velocity. And the third number is the vector r, that is r vector can be represented in this way, that r0 plus v0t plus half a t square, half a t square. Where is the acceleration? It is the time. In component form, you can write here also in component form. In component form, x is equal to x0 plus v0 xt plus half ax t square, and y is equal to y0 plus v0y plus half a y t square. These are the formulas will get motion in a plane with constant acceleration. The motion in a plane two-dimension can also be treated as two separate simultaneous one-dimensional motion with constant acceleration along two perpendicular directions. So we have explained all the other things and the formulas also, this formula, right? And we have to remember 4 formulas. Number 1, we have to remember these formulas also to know about the motions in a plane. The first one is v is equal to u plus at. Here v is the final velocity, v is equal to final velocity, u is equal to initial velocity, a is the acceleration, and t is equal to time. Number 2 we can find as a is equal to ut plus half a t square, a is equal to ut plus half a t square. Here s is the displacement, u is the initial velocity, so this can be remembered this way, right? So we are finding this one, right? So it can be remembered in this way, that a is equal to ut plus half a t square. Not only that, you can find also in another thing, that is another formula, that number 3 equal to v square is equal to e square plus 2as. These 3 formulas you have to remember later on for motion in a plane with constant acceleration. And whenever we take so if you want to learn all these formulas, first of all you have to learn all these formula, that is v equal to u plus at, a is equal to ut plus half a t square, and v square equal to u square plus 2as. These you have to learn first. Only then you can understand what is the motion in a plane we can do in different ways. These are the various factors we learn this formula. The v equal to u plus at, a is equal to ut plus half a t square, and v is equal to u square plus 2as. This is for general formula, but this acceleration can be replaced by small g also, if we consider it at acceleration due to gravity. if we consider this g as acceleration due to gravity, acceleration due to gravity, then we can replace this a by this form. That is we can write here as p is equal to u plus gt, and number 2, a is equal to ut plus half gt square, and the third one it can be also written as b square equal to e square plus 2 gs, where g is the acceleration due to gravity, where you can find the g as acceleration due to gravity, where you can find g as acceleration due to gravity. This is the acceleration due to gravity. So these are the various formulas you can learn. You can learn all these formulas also, and in this way we can find the different formulas in two-dimensional motion. In the next video we learn about two things, that is three things. We have learned about the relative velocity in two dimension and uniform circular motion, projectile motion. We do this in later on in the next chapter. And if you want to know something anywhere, who are in chat section, you can also ask any question regarding this video. And today we are dealing with class 11 physics, that is motion in a plane, and we are learning all these things. So anyone, if you want, any of the person want to talk here, you can ask any question according to your need, right? You can ask any question as you need. So these are the various, and also welcome to gaming video 8737. You have asked, you have invited as hello sir, and so if you want to ask any other question you can ask also. I want to reply in chat section also. And every day there will be a physics class of class 11. Generally this is a class of CBSE board, but it consists of all the board of CBSE and ICC board. Both are same, having the same, that is motion in a plane. So there will be online class every day in the morning, that is 6 a.m. to 7 a.m. Every day there will be online class. And I have told you that we will do this class every day from 6 a.m. to 7 a.m. every day. There will be online class of class physics on various chapters of class 11, that is for CBSE and ICC board also. Not only that, if you want online tuitions, you can take online tuitions from us. So for that you have to go to our description, and in the description below you will find the app link, and from there you can get our apps where we teach in the apps. We have a regular system to teach in the app, and YouTube also, and also we teach in YouTube also. So if you want this type of educational video, so please download our app. The name of our app is Pi Education. From there you can get all the videos, or all the necessary videos for class 11 physics. Dear friends, if you like this video, please thank you everybody for watching this video. Thank you.